this is my lab 3 for physics 2211. So to start, the purpose of this lab was to find the mass of a black hole as well as the speed of a spaceship. The fundamental physics principles were Newton's second law and gravitational force. So the main results we got was that the mass of the black hole was about 1.5 kilograms, or 1.5 times 10 to the 34th power, and the velocity of the spaceship was about 30,000 in the x direction, 30,000 in the y direction, and 0 in the z direction, meters per second. So the main formulas are forces of gravity, and then position update, velocity update, and general like Newton's second law formulas. So the results were that the only forces acting on the star was gravity of the black hole, and then for the spaceship it was also the gravity of the black hole and the planet. So the net force was just the force of gravity, and since we're in space, it's non-constant. So the average velocity was replaced with final velocity in the calculations, and if the net force was in the same direction of the motion, the object was speeding up. System is the black hole, surroundings is a star. Initial conditions, mass of the star was 2 times 10 to the 30th power kilograms, initial time was 0, delta T was the number of seconds in one full Earth year, and gravitation was 6.7 times 10 to the negative 11th power. So this is my code. You can see all the things I did, and then the orbit of the planet around the black hole. Planet's in yellow, black hole's in black. Yeah. Okay, and then for part 2. System was the spaceship, surroundings was the planet and the black hole. Initial conditions are about the same, except for now we have the mass of the ship and a mass of a moon. Wait a minute. Anyways, so you can see the results that we have the moon in the planet and the ship. So possible sources of error. I could have run the program for a longer time in part 1 to have an accurate mass, and then I also, like, as you can see in this image, I didn't wait for the entire orbit to occur, so I could have done that to fully check. So what it means is that they're identical mathematically, but one is simpler to quantify. This is just the difference between the net force and rate of change of momentum. So you would need to solve the ship, sorry, that's supposed to say ship, planet, moon system separately, and incorporate the influence of the ship, the planet, and the moon, and the black hole to, like, fully do it for the whole system. And yeah, that's all. Thank you.